You may have watched my previous video of my 3D printed 4-bit binary mechanical counter, but you still have questions about exactly how this counting in binary works. For example, how do you know that binary 0101 represents the number 5? Well, you could just use this counter to count up from 0001, which is 1, to 0010, which is 2, to 0011 or 3, to 0100, which is 4, and to 0101, and see that you've counted up to 5. But what about a bigger number like 1101? How would you know that that represents the number 13, for example? The good news is there's an easier way to figure it out. So if you're interested in finding out, in this video we're going to talk about how counting in binary actually works. Each of these binary digits, or bits as they're called, represents a certain weight, so to speak, based on its position. We count beginning with 0, so this first bit in the rightmost position is called bit 0. Its weight is given as 1. Now the rule is that each bit's weight is twice the weight of the bit to its right. So the second bit, bit 1, has a weight of 2 times 1, which is 2. And the third bit, bit 2, is twice that, which is 4. The last bit, bit 3, has a weight of twice that of bit 2, or 2 times 4, which is 8. Now our little counter only has 4 bits, but if we add another bit to the left of this, its weight would be 2 times 8, or 16, followed by 32, 64, 128, etc. This could go on indefinitely, but computers work well with a grouping of 8 bits, which is known as a byte. So when you hear terms like kilobytes, megabytes, gigabytes, now you know that they're referring to thousands, millions, and billions of 8-bit bytes. Incidentally, the 4 bits that our little counter uses, which make up half of a byte, are also known as a nibble. I couldn't make this stuff up. Actually, a more accurate way to determine the weight of a bit is defined as the number 2, since it's binary, which only has 2 values, 0 or 1, raised to the power of the number of the bit. So the first bit, bit 0, would be 2 raised to the power of 0, which is 1, because any integer raised to the power of 0 is 1. The next bit, bit 1, is 2 raised to the power of 1. And any number raised to the power of 1 is the number itself, so it would be 2. Bit 2, it's 2 raised to the power of 2, or 2 squared, which is 4. And for bit 3, it's 2 raised to the power of 3, or 2 cubed, which is 8. The next bit would be 2 raised to the power of 4, or 16, etc. So each bit only carries its assigned weight when its value is a 1. When its value is a 0, its weight is also 0. Now, a binary number represents the sum of the weights of all of its bits. So we start our counter with all the bits at zeros. So the sum of the weights of all its bits is 0. So 0000 represents the number 0. When we add 1 to the counter, by flipping bit 0 to 1, its weight becomes 1. So binary number 0001 is the sum of the weights, which is 1. Then when we add another 1 to the counter by flipping bit 0 again, it goes back to 0. But the way the counter is designed, when you flip a bit from 1 to 0, this little flag falls down and it also flips the bit to its left. So that makes bit 1 go from 0 to 1, which carries a weight of 2. So the sum of the weights of binary 0010 is 0 plus 0 plus 2 plus 0, which is 2. When we add another 1 to the counter, we flip bit 0 from a 0 to a 1. Note that this does not flip the bit to its left. Now we have the weights of 2 plus 1, so binary 0, 0, 1, 1 represents the number 3. When we add another 1 to the counter, we flip bit 0 again from a 1 to a 0, which also flips bit 1 from a 1 to a 0, but that also causes bit 2 to flip from 0 to 1, which carries a weight of 4. And so the sum of the weights of binary 0, 1, 0, 0 is 4. Add one more bit to bit 0, and it flips from 0 to 1. And now the sum of the weights is 4 plus 1. So binary 0, 1, 0, 1 is the number 5. Add one more, and bit 0 flips from 1 to 0, flipping bit 1 next to it from 0 to 1. So the sum of binary 0, 1, 1, 0 is 4 plus 2, or 6. Adding one more to bit 0 flips it from 0 to 1. And the sum of binaries 0, 1, 1, 1 is 4 plus 2, or 6, plus 1, which is 7. Now, when you add one more to the counter, bit 0 flips from 1 to 0, flipping bit 1 from 1 to 0, which also flips bit 2 from 1 to 0, and that causes bit 3 to flip from 0 to 1, which carries a weight of 8. So binary 1000 is 8. Now you can see how as we keep adding 1 to the counter, we next get to binary 1001, whose sum is 8 plus 1, or 9. Then to 1010, and 8 plus 2 is 10. Next is 1011, and 8 plus 2 is 10 plus 1 is 11. Then comes 1100, which is 8 plus 4, which is 12. Then 1101, which is 8 plus 4 is 12, plus 1 is 13. 1110 is 8 plus 4, 12, plus 2 is 14. And finally, 1111 is 8 plus 4, 12, plus 2, 14, plus 1 is 15, which is the highest number that we can count to with just 4 bits. But before I flip it, notice that bit 3 has its flag down, which would flip the bit to its left if it were there. And as we saw earlier, that would carry a weight of 16, which is the next number, so counting would just continue from there. But since that's the end of the line for our counter, when we add 1 to it, each of the bits flips the 1 to its left, from 1 to 0, and we start over counting from all zeros. So I hope that helps you understand counting in binary. Thanks for watching.